Okay, welcome everybody. I'd like to introduce Erich Baumgartner, who's going to lead our session today. Erich, I will pass it over to you. You can give a little introduction as to what we're talking about.
Great, thanks, Kate. Hello, everybody. Good evening. I am Erich Baumgartner. I work for Northern 911, and I've been in the telecom/911 business for over 20 years now. I'm currently with Northern 911, and I have 20 plus years prior to that with Rogers. So I have quite a vast knowledge on wireless 911 and emerging mobile services. So going to take us through our ENP study group session for today. We're going to be covering off sections 2.12 to 2.12.6, sorry, 2.13.6 of your study guide. In this session, we're going to be reviewing and explaining wireless emergency calls, how location is provided and delivered to the correct PSAP. We're going to describe a little bit the evolution of how location has been provided and the use of handset-based location, network-based location, and how wireless emergency calls are transmitted through E911 or NG911 systems to support rapid emergency response. Now, as you can see in the table of contents, we have a lot of items to cover. Wireless 911 has been around for 20 plus years, and as we all know, location initially started with nothing. It's been getting better and better as time goes on. So we'll go through the whole evolution of it. I've tried to throw in some fun facts to keep things a little bit interesting. We're going to be going through a lot of acronyms, so there are some things that you may have to maybe read a few times and memorize. I'll maybe try to give you a couple hints, things that I've been told or coached at on how I can maybe associate or remember certain terms and how they work. So let's get on with our wireless discussion. So wireless cellular 911. First, I thought I'd give a couple facts about wireless services in Canada. First Canadian wireless call was placed in 1985. That happened on July 1st, and it actually happened in Toronto, Nathan Phillips Square. At that time, the mayor, Art Angleton, used one of those old, bulky mobile phones to call Mayor Jean Drapeau from Montreal. Initially, for wireless emergency calls, they were really treated as basic 911 services. They didn't have all the bells and whistles, let's say, that you have today. And wireless calls, as I mentioned, was an evolution and have really progressed to the E911 services that we use and see today. So first, looking at phase 0, which is basic wireless 911. So funny, when we first started with wireless 911, there wasn't really any known phase 0. We started with phase 1 and then phase 2. And when we look back, we said, oh, there's an area or a time where it really had no location at all. So we know that now as phase 0 for basic 911. Essentially, a wireless carrier, they would still provide a 911 type of service, but it would translate the digits 911 when a user dials it on their phone to a 10-digit PSTN number. That would be for the PSAP or call center to receive the emergency call. At that time, they were simply regular PSTN calls, like me calling you. They did not go through a 911 network. You often see something similar to this today with unserved areas where maybe there's no PSAPs, but carriers still route a 911 call to a 10-digit number. Also, when we did have phase 0, there were some wireless carriers, wireless service providers, that's a WSP, that were able to provide a caller ID, but as I mentioned, they had no location. So some of them had ANI, but no ALI. Where they didn't have caller ID, it was really one of those unknown numbers. You knew nothing when picking up the phone at the PSAP. You had to get the phone number, you had to get the location, absolutely everything from the caller who placed the 911 call. So I mentioned the term PSTN. PSTN is your public switch telephone network. It's really your traditional global telephone network. Historically, that's where all voice calls were carried. They were all done over circuit switch lines. That's your old analog type of service. While communications have changed and evolved over the years, we now really rely on IP-based networks PSTN still is that backbone of the phone network, where everybody places calls and talks to themselves. It's that old landline calling, and it still interconnects with mobile services to emergency services. So first, we're going to get into a few terms. Let's maybe get those out of the way, and you'll see them as we go through the different phases of wireless evolution in the next few slides. So these are terms that you're going to see quite often in wireless discussions. You'll see them on the ENP exam. The first one is going to be your PANI. Your PANI stands for Pseudo Automatic Location Identification. It's an ALI record there is an ALI record that's associated with the PANI, and it's really configured to provide the location of the wireless cell site or cell sector. It's really information about the coverage area of that cell tower. When you see PANI, it's really a generic term. Often you'll hear the term ESRK or ESRD. PANI is the generic term of both of those. The next term is ESRK. ESRK is the Emergency Services Routing Key. That's a 10-digit number that identifies an emergency call placed from a wireless device, and it uses the ESRK to route the call through the network, the 911 network, and deliver it to the PSAP, and also used to retrieve associated ALI data, the cell site location. ESRK is very much a routing key that's used in the US. We don't use that in Canada, but in your ENP guide and exam, we do look at some of the wireless functionality in the US. So we will be going through both of these terms and scenarios. A little bit more of focus on Canadian, but we will also go through how things work in the US. The next one is ESRD. ESRD is kind of the equivalent of an ESRK, and that's what we use in Canada. ESRD is the Emergency Services Routing Digit. It is a 10-digit phone number that really uniquely identifies the base station, which is the cell site or sector. It's that cell tower where calls are routed to from the cell tower to the emergency 911 network. An ESRD may also be used by the PSAP to retrieve ALI information. That's really your cell site specific location. Next page, wireless terms, we have an MSC. An MSC is your mobile switching center. In the wireless world, that's something that's a part of the wireless service providers network, and it's really the equivalent of a central office. It provides switching functions for wireless calls. We then have the MPC or GMLC. That's your mobile positioning center or gateway mobile location center. That is also an element that's on the wireless network, and it provides calls to the emergency services network. The MPC GMLC gets a call that's placed from a mobile device. It receives it and it forwards it and to the 911 network, and it really controls and is one of the main pieces that's responsible for location services from a wireless carrier's network. The next two terms are CAS and NCAS. So these are terms that are very often used in the US as well. CAS is your call path associated signaling. So it's a way to signal calls, and it's a method of delivering wireless calls and in which the phone number and other associated data get passed from the MSC, the mobile switching center, to the PSAP, all in one voice path. So any information that you have with the voice call, it all goes down the same way. Your NCAS is then your non-call associated signaling, and that's a method of delivering 911 calls where the phone number and all other call data is really passed from the mobile switching center to the PSAP outside of the voice path. So you essentially have two paths where the traffic or voice call goes. You have the voice path where the voice call goes, and then your alternate path where you may have all that rich data that's delivered to the PSAP. By rich data, I mean callback number as well as location. Now, I was told an interesting analogy that made CAS and NCAS really stick in my head from another ENP study group that I was at. think of CAS and NCAS as a school bus and maybe a racing car as to when you have to take your children to school in the morning. CAS is everything goes in one voice path and they're all delivered the same way. You always have the same route. Nothing ever changes. So CAS is like your school bus. All of the kids get into the one school bus and then they travel the same way every day, right from the start to the destination. So that would be your voice path. Your NCAS is then considered your race car. It could take a different way to get there other than just the school bus. So essentially, every child may jump into different race cars and they would have their different ways to get to the destination. They're not always taking the same route. There might be traffic. They may go off a different way. So in my head, I always thought bus is CAS, 3-letter words. Race car is NCAS. They're a lot more than the 3-letter. That was just an easy way for me to remember. And I thought a very clever way to doing it. So I thought I'd share that to help you guys out. We'll get into a little bit more of NCAS and CAS as we go through our slides and presentation today. So first, we will talk about wireless phase 1. Wireless phase 1 was really that first way to get some location about a 911 call. So in the US, they had their first report and order. That was order 94102. And in there, they mandated all wireless carriers to deliver cell sector information and a callback number for a wireless call to the PSAP. So essentially, when a PSAP gets the call, we still see it today. You get your phase 1 information, which is some sort of location about that cell tower, where the call originated from, and the callback number. So originally the 911 network was based on camera trunks, and they could only deliver one 7-digit number, so the ANI, to the selective router, and also an 8-digit number to the PSAP. That 8-digit number was a 1-digit plus a 7-digit ANI. This was required by PSAPs in order to query for a callback number. So that is really your NCAS that we talked about earlier. They would get the voice call, they would get an ANI, then they'd be able to query the ALI database and get some wireless cell tower location. Later protocols between the MSC, so the mobile switching center, and the selective router, the PSAP supported 20-digit numbers. So at that time, they were really able to put the callback and that PANI, the ESRK in the US, all together in one packet. So that really meant that all the data elements were able to be carried in band with the call. That's your CAS situation that we had before with the analogy about the school bus. So here is a little diagram as to how wireless phase 1 works, and this is really particular about the US. I grabbed this diagram from the ENP manual. It's a really good one. So again, with that FCC mandate, carriers had to deliver cell site information and a callback number for a wireless 911 call to the PSAP. So this is a diagram, and on the left you have the call flow as to how it worked. Unfortunately, I noticed afterwards that we actually have a race car down here, but ignore the race car. That's more just a mobile phone. As you see, it says right above it, 911 dialed. So with this call flow, what happens is a wireless call is placed from a mobile phone, and it hits the cell tower, which is part of the network of the wireless carrier, and then that's forward internally within the wireless carrier to the MSC, their mobile switching center. At that time, the MSC identifies the cell sector and the callback number, the CBN info, and that's sent up to the SCP. The SCP is a service control point, which is really a component of the SSF system to control the service. And in there, the main reason for it is it gets routing information. So that SCP, it selects a PANI, and in the US, that's your ESRK. And the ESRK is what identifies the call as an emergency call and tells the call where to go, what PSAP it has to go to. So it assigns the ESRK, and then the MSC sends that out to the 911 tandem or the E911 selective router. At the same time, that SCP, the service control point, sends the callback number and the PNE to the ALI database. That creates a dynamic record. It's a temporary thing, and that's used for the PSAP to query afterwards. So after that, the voice call and the PNE essentially get routed to the PSAP. The PSAP gets that displayed on their system, and they have that voice call, and they use the PNE to query the ALI database. And then the ALI database returns the phase 1 data to the PSAP, which is your cell site sector information, that phase 1 location information. So that's how it works in the US. It's a little bit different with ESRKs because it does a query to the ALI database afterwards to get that cell tower information. The ESRK in this scenario really creates that dynamic record in the ALI database with all the caller information and the cell site information. So a little bit different as to how it works in Canada. But this is also a really important step because there are questions on the exam about PNEs and ESRKs and ESRDs. So really something key to have a proper understanding of. So then we move on to Canadian wireless E911, and this is phase 1. In Canada, this was really our first big wireless decision. It is decision CRTC 2003-53, and it's our wireless 911 decision. Essentially, in that decision, there were two big things that came of it. There was a mandate where E911 was available from the ILEC, so there was a 911 network with a PSAP that's interconnected. Wireless carriers had to provide wireless E911 service to their subscribers. Also from that decision, wireless carriers were mandated to provide a toll-free, a 1-800 number to PSAPs, and that was to provide subscriber information in emergency situations. Many PSAPs use this phone number today. We use it maybe during a 911 call or afterwards to get more information, humanitarian letter, or to do rebids, potentially also get billing address. This phone number was even more important back in 2003 when we first launched the service because wireless phase 1 location only give you a cell tower. It didn't give you that pinpoint location of where a caller was. So these numbers were used a lot more often than they are today, just because we didn't have all that more rich information that we do have today. So equivalent to in the US, we had a 20-digit wireless phase 1 where a callback number and the PNE, in this case that PNE generic term meant the ESRD, they get delivered over the SSS trunks to the E911 tandem. So the ESRD is really used to query the ALI database to get your phase 1 location information. That's your cell sector location information. When a wireless carrier installs a cell sector today, they create and add ESRDs to the ALI database. That's how a location is queried, and we know when to route the call, what location to provide to the PSAP. So different than the US, any wireless carrier that originates a call from a specific cell site sector, they all have the same ESRD number. They all have that location of the cell site where it was installed. So wireless phase 2. The FCC, after a few more years, had wireless phase 2 that came out. And that was really to improve the effectiveness and reliability of 911. Also providing 911 dispatchers more information about the call. So that's where we really look to get that XY coordinate of the caller. Under phase 2, wireless carriers had more mandates, and they had to provide that specific precise information to PSAPs, and that's specifically the latitude and the longitude of the caller. From the SEC standpoint, this information had to meet certain accuracy standards. It had to be generally within 50 to 300 meters, and that really depended on the type of technology used. We're going to get into in the next few slides a little bit of what those technologies are. So for wireless phase 2, calls were still delivered to the appropriate PSAP, as we outlined in the previous diagram from wireless phase 1. That still works the same. It's just additionally after that, wireless carriers would have the caller's XY location delivered to the PSAP. Wanted to have a quick touch on your location for XY coordinates. Really important to be very careful about XY coordinates. And I have a little bit of blurbs down at the bottom there. A lot of people will say lat long and XY. Now, when you look at that, saying XY does not really mean lat long in the same way. XY really means long lat, because your longitude is really your X coordinate. So that's your horizontal, your east to west, and your Y coordinate is your latitude, which is your vertical, your north to south. So very important from that perspective. We're also going to touch a little bit on Z afterwards, and your Z coordinate, which came much later, is really your height, which is also known as your elevation or your altitude. Okay, we're going to touch a little bit on wireline compatibility mode. This is really a term that's specific to phase 2. When phase 2 wireless call routing was introduced, in order to provide all of the information, your PNE, your phone number, your PNE being your ESRD or your ESRK, specifically in the US, your ESRK, they introduced something called wireline compatibility mode, WCM. For wireless phase 2, a wireless caller's XY coordinate is calculated by the network, and that's really mapped to a temporary wireline style alley record. So it really looks a lot like how things work from a wireline perspective. Then afterwards, that was delivered to the PSAP through all legacy wireline 911 interfaces. Important to know that wireline compatibility mode, if they wanted to not leverage this and do things in the new way, there would have been a lot of enhancements needed to the alley database, the 911 network, as well as PSAPs. So wireline compatibility mode was really a way to make wireless 911 calls work, having it look like a wireline style alley record. And it didn't mean that you needed to do all the enhancements. You didn't need to engage vendors and spend money to enhance networks. Things still work from that perspective the same way they did before. So when you hear wireline compatibility mode, keep in mind it's something that's really a wireless phase 2 911, sorry, a wireless 911 phase 2 term. That is where it's used, and it's predominantly was used in the US. All right, so there are really alternative ways of delivering 911 phase 2 calls. And again, we're going to discuss a little bit about the NCAS and CAS. So way back when wireless phase 2 was introduced, there was a joint ATIS and TIS standard. They really do a lot of the standards from a wireless provider standpoint. They say how mobile devices work, how routing works, things like that. So there were two ways that they could potentially do it. The first one was NCAS for a wireless phase 2 911 call. In that scenario, your PNE, so your ESRK in the US, and a callback number would be delivered from the MSC, the Mobile Switching Center, to the selective router and the caller's XY coordinate to the alley database. All of those three elements, because it's NCAS, are not delivered in band with the call. So they take the different paths. You have your voice channel, and then you have your data, which goes different ways. There was also the possibility for CAS and doing that during a phase 2 911 call. And in that scenario, you would have your PNE, so your ESRK in the US, the callback number, and the caller's XY coordinate, all delivered from the MSC, the Mobile Switching Center, to the selective router, and all three would be delivered right to the PSAP. Now, very important, in theory, this sounds really good. You would get the call and you'd have everything there all at the same time, but it really wasn't practical for a proper implementation for a bunch of technical reasons. First, when a 911 call is placed, you're able to quickly identify what cell tower, your ESRD or your ESRK. You're able to send the call to the PSAP, but you don't know the XY location of the device. That takes a little bit of time to determine. So that wouldn't be good if we had to hold on to a call before sending it to a PSAP and wait to compute what that XY location is of the actual caller, where the device is located. That would seriously delay the ability for calls to get over to the PSAP. So there were very few PSAPs that were capable also of receiving that type of data directly over the selective router. So in the US, they really looked at something like CAS doing it out of band, so that you didn't have any of these types of delays for delivering wireless 911 calls. When they first launched the service, it could take up to 50 seconds to really get that XY coordinate of the caller. And imagine trying to place a 911 call and waiting 50 seconds just to have that call ring at a PSAP. Wouldn't be good. So they had to do these alternate ways of doing it.
Erich, we do have a question here.
Oh, yes.
Would the CBN be identical to the number in which the 911 call is coming from, or is it a different unique number?
Yeah, your CBN is the phone number of the originating device. So whatever the caller's phone number is. It's your callback number, another way to look at it. Number gets disconnected, that's the number you use to engage that caller again. No problem, Cynthia. All right, on to Canadian Wireless E911 Phase 2 now. So in 2009, this was really the second really big decision from the CRTC with regards to 911 calls and providing location. So this was Regulatory Policy CRTC 2009-40. In the presentation that you guys have, you have the links here, and you'll be able to click on those and go have a look at what those decisions are later. In that decision, there were really a couple, 2 or 3 big items that were very important. First, for routing a 911 call, again, because of the setup we talked about on the previous slide, it was really important to preserve that wireless E911 Phase 1 for routing a call. So a wireless carrier would determine the cell site sector, and right when it gets that, which it knows very quickly, send that call to the PSAP. Afterwards, it would look into providing wireless E911 Phase 2. Now, in Canada, they were actually deployed in 2 different stages. And you don't hear that too often, but there is a stage 1 and a stage 2. Stage 1 was really just the ability to provide that caller's location to the PSAP. Excuse me. So that's the XY location of where the caller is on top of the cell tower information. After that was deployed, then in Canada, we looked to deploy stage 2, and that was really in-call location updates. So that came a little bit later. Your in-call location updates, also known as your rebids, that's where when you're in a 911 call, a PSAP can do rebids every 30 seconds to be able to see where that caller is. If they're moving, if they're in a car going down the highway, you can get updated locations as they move during that 911 call. So again, very important, calls are delivered to the appropriate PSAP as we looked at in the wireless Phase 1. And in Canada, that's your ESRD-based routing. Then for wireless carriers, as we touched on, it was really to provide that XY location. Now, in Canada, we did take a little bit of a different approach than the US. So this is where we don't really refer things too much to CAS and NCAS, but we selected what's called the Open Mobile Alliance Mobile Location Protocol. So that's the OMA MLP, and that's really something between the MPC GMLC, that wireless network location platform, and the ALI database. So that was really used as a means to query and get a response for your Phase 2 geodetic location information. And in Canada, that location of the caller, the XY, we really have established a certain radius of uncertainty around where the caller is with a set confidence of 90%. So when we first launched 911 services and we had wireless phase 2, XY coordinates of the caller, they were not exact pinpoint locations. They at times could be a little bit more in the area, maybe a few meters, but in some situations, depending where you are, maybe up to 100 meters or 150 meters. So that's where we implemented a radius of uncertainty and a confidence level to say, hey, we're 90% sure that they are within this circle from the dot on the map where that caller, that XY of the caller is. So Canada Wireless Phase 2, I was able to dig up a diagram. I found this on one of eSwig's contributions that were submitted many years ago. So this is, I guess, courtesy of Bell. They provided in that public contribution. There is the link down at the bottom of the presentation if you are interested in getting more details about it. But this is a fairly good diagram as to how wireless phase 2 works. So in the top left, you can see that cell tower. Again, everybody likes using race cars. A caller would place a 911 call, and that would go to the wireless carrier's MSC. You then see that yellow line going to the right, and that would be the call, the voice call with the ESRD, which is a 519 phone number, as well as the callback number of the caller, 416. So in this scenario, it really shows that the caller has a phone number that has been assigned a 416 number, so maybe a resident of Toronto, but being the ESRD 519, they were actually in London, Ontario. Your ESRDs always have similar types of phone numbers that still have the area code of the exchange that the cell tower resides in. So following that path on the top, the call with the ESRD and the callback number would get sent to the primary E911 tandem, and that would get routed the voice over to the primary PSAP. The ESRD would do a query of the ALI database in the orange, and that would provide your phase 1 location information. That is the location of the cell tower cell site sector. So this is a little bit of an updated diagram, but very similar to the one we previously looked at, the previous one, more US-centric. Once the PSAP got the call, it was important to get their Latin long of the caller. So that's where from the PSAP, it sent a request, and all location requests go down to the ALI database. The ALI database here would be notified that, hey, this is a wireless caller. I need to go back to the wireless network, so that mobile location server on the bottom, and in order to determine what the XY of the caller is. This mobile location server would interact with the MSC, and it would do a query with the actual device or the network to say, what is that more precise XY location of the caller? Once it had that, it would get sent back down to the bottom along the black arrows and up to the PSAP. So then essentially the ALI display, which you would get after all that completed, is your phase 1 information, along with number 2, the lat long of the caller. And as noted here, when we launched phase 2 in Canada, that could have been up to 50 seconds. Now, as things evolved, we say up to 30 seconds. However, really the way wireless and networks go now, it does happen much, much quicker than that, but we still see 30 seconds. I think I see a hand up from Jason.
Yes, this diagram is awesome. I love it. One question that's been in my head for a long time is these ESRD/ANI numbers. How many does a cell site have? They're dynamically assigned. I presume if 2 people call 911 from the same cell site, they have to be dynamically given separate ANI numbers. And then after the call is done, do they get recycled? I just wonder how many ANI numbers are in each cell site and how they get recycled.
So in the US, I'll say they have a block of numbers, and every call gets assigned a different ESRK number. We do a little bit different in Canada, where when you build a cell site, that cell tower only gets one ESRD record. Now, sorry, I'll clarify, the cell sector gets one ESRD record. So you may have a cell site that has a serving area here and a serving area this way and a serving area this way. So that tower would provide, I guess, 3 different areas, and they may have 3 different PSAPs around, if you can see my hands move. So each cell tower could have multiple ESRDs up to the amount of cell sectors they have. So a wireless carrier would assign that. Now in Canada, when a 911 call is placed, it uses from the cell tower, and it sends the ESRD plus the callback number of the caller. So you can see right here beside the MSC, it has the ESRD record with the callback number. So both of those values get sent. So it can always use the same ESRD record, and that is what's used to query the ALI database to get the actual location of that cell tower. So if you have 100 calls from a cell sector, all 100 calls will have the same ESRD record because they're all from that same location, but each call would have a different CBN number depending on what is the assigned phone number of that mobile device. Does that answer your question?
Gotcha. So that means then the PSAP queries the ALI database with both the ANI and the CBN at the same time. Is that correct?
Initially, for phase 1, it only uses the ESRD record. Afterwards, so essentially, yes, both get queried to the ALI database. The ESRD record immediately gives the location of that cell site sector, and that's really done very quickly, right when the call gets delivered to the PSAP. It's the phone number that takes a little bit more time. The PSAP really does that query to the ALI database, and it's all relatively automatic for that initial phase 2 location. And using that phone number, it goes back to the wireless network, gets the XY of that specific phone number, and then sends that back down to the PSAP. So that takes a little bit of time because it goes from the ALI database back to the wireless caller. That's why it has that 50-second window from when we launched phase 2 in Canada.
Gotcha. Okay, so the CBN makes it the unique thing so that 2 911 callers don't get the same lat long and such, right?
Of the caller, yep, you got it exactly. They'll get the same ESRD location, but not the same CBN location, unless they're standing on exactly the same spot, of course. Yeah.
Gotcha. Okay, that answers my question. Thank you.
Great, no problem. All right, moving to the next slide. So we're going to talk a little bit about location services. Traditional location, as I said, of course, with phase 1, phase 2, location is always evolving. We're always able to get more and better, more precise location information. When we first launched wireless services, we really only had network-based location, your more traditional location. That was a method of determining a caller's location, which is really estimated by the wireless carrier's network. It had nothing to do with the phone itself. As phones evolved, we later, as we all know, ended up starting getting GPS chips into our phone. GPS chips then had the ability to do calculations right in the device, and that is known as handset-based location. So it really is an improved location from the network-based, and you can get a little bit of a more precise information because of technology, and that GPS chip is right in that device itself. As things further evolved, and more recently, when we talk of location services, there's the very precise, I'll say, location service called device-based hybrid, DBH. That is really a method of determining a caller's location from the mobile device being the central determination point. Now, that said, it uses handset sensors, maybe your Wi-Fi sensors, barometers, things like that. It also, because it's hybrid, it also uses network measurements, and it's able to provide a very precise, single, more accurate location. As we all know, we have different mobile phones today. Generally, you have a lot of Apple devices and then a lot of Android devices. So each of them has their own different way to provide device-based hybrid locations. Your Apple devices, which use the iOS operating system, they have what's called a hybridized emergency location. That's called HELO. And developed by Google for all Android devices, they have ELS, which is your emergency location services. So if I look at the more traditional handset-based location and network-based location, try to put together a little chart just to show you the differences in how things worked. So from a perspective of where the location is calculated, as I noted, your handset-based location, it happens on the phone. Network-based, it's on that carrier's network. You do have some main technologies on the handset, which use GPS and some Wi-Fi and other sensors, where your network-based location is really your cell tower triangulation. In terms of accuracy, handset-based can be much, much higher accuracy than your network-based location, especially for network-based if you're outdoors. Indoors. There can be a lot of concerns or poor performance when it comes to that. So dependency on the phone, your handset-based location, as mentioned, you generally have to have a GPS chip in that device. So it does require a compatible device to make that work. But your network-based, because it's network and cell tower triangulation, it would work with any phone. The older phones that have no chips in them, no smarts per se, you can still get a network-based location from those types of device. So a little bit about GPS, your global positioning system. Try to add in some fun facts and just to explain a little bit what GPS is. Many people may already know. GPS is really a space-based navigation system that provides location and time information in all weather conditions anywhere on the Earth, as long as there's really an unobstructed line of sight. Try to throw in a few fun facts about GPS. It originated during the Cold War, back in the 50s and 60s, and that was based on navigation concepts. 1973, the U.S. Department of Defense had that idea to use it for multiple military programs and really combined everything into a single global system. In 1978, the first GPS satellite was actually launched into space. And in 1995, we had the full constellation of 24 satellites that really became fully operational around the globe. Now, initially, that was all for military use, and there's always a lot of concern, secrecy, privacy around that. But in 2000, what's known as selective availability was turned off. And this actually introduced the ability for a GPS to become a reliable system for use in aviation, navigation, and of course, emergency services. So again, while it was originally for a military purpose, your selective availability, while it was available for other sources like aviation and navigation, it introduced a lot of errors. They didn't want it to be too precise for civilians and civilian receivers. So it really prevented adversaries from using a precise GPS positioning. So a few fun facts there, a little bit about GPS. Then we get into the phone world and something called a GPS. I said when we all have your GPS chips on your phone, that's actually known as a GPS. It's assisted GPS. So that's key for your handset-based location. And what it does, it really helps with how quick and accurate your device can find a location. As mentioned before, GPS can be a little bit slow, maybe unreliable in cities or when you have a weak signal. So a GPS, while it uses satellites, it also uses your cellular connection and data connections for assistance from your wireless carrier to really speed things up. So again, it uses a chip on the mobile devices. And when you hear GPS on your phone, it's actually an AGPS chip. It's assisted to just improve things, make things a little bit better and quicker. It's a great technology. So a little bit about UTDOA. UTDOA is really how cell towers work when we talk about network-based location. And it really has a lot to do with the time differential of arrival, where it measures the amount of time a signal goes from a mobile device to all the cell towers and back. So based on that distance, it's able to perform some calculations and determine how far away to essentially narrow down and pinpoint you to an XY coordinate. So again, it takes the location, it takes a signal from that device to a cell tower and back. You can see in the diagram, you have the white dot in the middle. That's your target, your mobile device, and your B1, B2, and B3 are your cell towers. So with the amount of time the signal from that mobile device in the center goes out to B1, B2, and B3 and comes back, it can say, hey, I'm close to B1, I'm very far from B2, so I'm further away. And it can really use that to narrow down what your XY coordinate is. So for that, again, you don't need that chip in your device. It's a network-based technology, and it can be used for any type of device out there, even an old one from the early 2000s. The one challenge with using your network-based location, it's really not good in rural areas and along highways, anywhere where there may be not very many cell towers. As you see from the diagram, you need 3 cell towers or more to really narrow in and get you a proper coordinate. If you have 1 or 2 towers, you really can't narrow down that location because you need those 3 bigger circles to give you that pinpoint where that white dot is in the middle. So that's why, while network-based location was available, it's not as good as your AGPS in the handset or your handset-based location. Indoor technology locations. So again, as time has progressed, and the FCC in the US is a little bit quicker for providing some of these enhancements than what we've seen in Canada. Of course, over the past 20 years, we've been able to deliver XY coordinate of a caller, which is great for a location outdoors. But what about inside? You kind of need more information. Even me, myself, I'm in a condo building in Toronto. If I place a 911 call and there's an XY coordinate, first responders can come out to locate me, and they'll see that I'm in a 50-story condo building. They'll have no idea what story I'm on. So the FCC really in 2015 started to push their first set of rules for providing that Z-axis location to get an elevation of a caller to really help in these bigger city environments where you don't want first responders searching through hundreds and hundreds of units to locate a caller. They can get something more precise and really narrow down where that caller is, or at the very least a starting point to search for that caller. In the US, when they did launch their first mandate, they said wireless carriers did have to provide a Z-axis, so that elevation, and it had to be accurate within a plus or minus 3 meters. And that had to be done for 80% of the calls. In addition, with other indoor location technologies, in 2020, the FCC really aligned their wireless accuracy requirements with a lot of the rules governing MLTS systems, your multi-line telephone systems. So what they were looking for in the US is to have calls delivered with a more precise or dispatchable location. In that case, they would include something like a street address, an office or apartment or a room number, etc. Through MLTS discussions and review, you can see that within a location, you can really narrow down to a more precise location, and that's what their rules in 2020 tried to govern from a wireless perspective as well. In Canada, while we are a little bit behind, we are doing a lot of work on Z-axis. It's something that we are reviewing currently in the CRTC's Emergency Services Working Group. So we're looking at the Z-axis and how that can properly be delivered to a PSAP, how it would be calculated and processed. We want to make sure it's accurate so that when a PSAP gets that, in addition to the XY they see today, tomorrow they will get a Z coordinate. Not yet too sure when that tomorrow is. Hoping fairly soon, but it still could potentially be a year or two, maybe a little bit more. The Emergency Services Working Group is investigating that. I think this might be my final slide on other resources and related information on wireless location determination technologies. So this I grabbed right from your ENP study guide. It provided a link, which is a very good document on additional information on locations. It's known really as supplemental information. So it's things that would be provided after the call. So it was something that was developed by NENA, the National Emergency Number Association, the National Association of State 911 Administrators in the U.S., as well as ICERT, the Industry Council for Emergency Response Technologies. So they really worked together on this document to provide further guidance and potential use for PSAPs on all the different types of location data that may be provided as supplemental information. Again, it's additional data provided extra, but it's a really good guide on some of the details, technologies that are out there, all the extra location types of data you can get so that 911 callers can be quickly and accurately located and dispatchers can find them as quickly as possible. So that wraps up my presentation. Got my email address there. If anybody has any questions, you can reach out. Otherwise, maybe just wanted to see if anybody had any questions. Again, if nothing now, you can always reach out to me afterwards. I'd be happy to help you out on your quest to get your ENP.
Eric, there's a question in the chat. I'm not sure if you can see it there.
Oh, I don't see it.
Cynthia, do you want to come off and ask your question?
Yeah, no, for sure. So it's a quick question. First off, this was a great presentation, Eric. This is absolutely fascinating. Lots of fun to listen to you speak and the information that you have. Quick clarification on the slide with the definition of PSAP. Should it actually say automatic number identification? Because I think it said automatic location identification on that.
If I said that, you're completely right.
One more. There it is on the top.
Yep, I to fix that. Yeah.
Okay. No, that'd be fantastic.
Yeah, I'll fix that in the final in the final version that we have posted. Yes, very good catch. But again, key, just remember, PSAP is very much a generic term. It really means ESRK or ESRD, but you will see, or at least I saw in my exam, a lot of PSAP being referenced.
Okay, sounds good. Thank you.
No problem. Dave, I think I see your hand up.
Yeah, Eric, just to clarify on that, actually, PSAP, it's I think your text is actually right. It's a pseudo alley record associated with a PSAP.
Yes, that
Right?
might be right.
It is the alley. The PSAP creates the pseudo alley.
Yep.
Then I get confused with
information. Yeah,
that
so
gets
the
confusing
way
with
that
the alley,
the definition of the term, it should have been PSAP is pseudo ANI, but it's an alley record that's associated with a PSAP.
Yes. Yeah, you are.
Well, that's a weird one to describe. I know it was confused me. I wrote this test 5 years ago, and it was like.
Yep. No, you're completely right, because that's really what's used to query the alley database. So yeah, they should have said PSAP when they initially did it. I think maybe pseudo ANI because it's actually a phone number. The PSAPs is a 10-digit phone number as we know it today.
Right, and it's pseudo because it is actually utilized to query that alley record, because there's no ANI record there. It's got to be created so it can go find the alley.
Yeah, there you go. Yeah, you are right. And see, I don't say the whole word, the whole acronym out all the time. I just say PSAPs all the time. So that's a good catch and interesting points. Yeah, that is why. Thanks for your help on that one, Dave.
Yeah, no worries.
Any other questions? If not, I think back to you, Kate.
Excellent. Thanks so much, Erich, for your presentation here. I'm really glad that you were here to answer some of those questions. You certainly have a lot of expertise, so we very much appreciate you presenting today. And he's also been able to answer some of the questions that have come up as a result. And we're going to make sure that all of those questions that have come up are also covered by the end of the session. So as soon as this recording is done, I'll move it into the folder. You can all access it along with the PDF copy. So thanks so much, Erich, again. Appreciate it. Everybody have a great night. Thank you.
Thanks, and good luck on your exam, everybody.
Thanks, Erich. Good night, everyone.